Okay. All right, we're looking at this assignment on Khan Academy, normal distribution area above or below a point. We took the student's height 103.1, we subtracted the mean 105, we divide by the standard deviation 10, so that's negative 1.9 divided by 10, which is negative 0.19. We look at the negative side of our z-score table, we go over to the 0.09 column, and we get 0.4247, so it's that proportion of 1 is below. This is my normal distribution shaded below, like we see at the top of that chart. And so if we want to know the proportion of students that are lower, that should be the answer. So now we're going to check and see if we got it. Cool. So remember, this chart gives us numbers below. So if we find a number on our Z chart and we're trying to find anything lower, then we use that actual number. If we're trying to find above or higher, then we would take the number we get from the chart and we would subtract it from 1. And that will give us this portion right here. Okay, set of geography exam scores are normally distributed with a mean of 75, standard deviation of 10. RM got a score of 76, so we're going to go 76, subtract 75, divided by 10. Why did they do a standard deviation of 10? So that it's really easy to just go, oh, that's 0.1. And then I'm going to look at the chart, and that's a positive 0.1, not a negative. So make sure you're on the positive side. Positive 0.10, so that first column right there would be 0.5398. Let's try it really fast. Oh, my mouse doesn't like that my pen is on my tablet. Okay, 1 second. Let's check it. Awesome, we're gonna record. A set of average city temperatures in July are normally distributed with a mean of 23.5 and a standard deviation of 2. The average temperature of some place is 23 degrees. So I'm going to go 23, subtract 23.5, and then we divide that by 2. So we get negative 0.5 divided by 2. I should be able to do this in my head, but apparently my brain doesn't want to. So pulling out my calculator, 0.5 divided by 2 is 0.25. Duh. Yeah, I really should have been able to do that in my head. Okay, so negative 0.25, that's our z-score. So now we look up that on the chart. So we start by looking for negative 0.2, and which is near the bottom. And then we go over to the column that says 0.05. So 0, 1, 2, 3, 4, 5. And it says 0.4013. But we want higher than. This would be below because that's off of our chart that is the stuff below, right? So if we want above, that means we need to take 1 and subtract 0.4013, which I should also be able to do in my head, but I don't want to. And I get 0.5987. And I check my answer. Ta-da. Okay, here's another one that's higher. So a set of high school student heights are normally distributed with a mean of 161 centimeters, standard deviation of 15. McKeo is a high school student with a height of 191. So our data value is 191. Our average is 161. They're trying to make these numbers relatively easy to work with, aren't they? So that is a z-score of positive 2. So I look at the positive side of my chart, and I find 2.0. First number there is 0.9772. So again, that is the portion below, and it's a big portion because This is like 2 standard deviations up here, right? So to get the number we want, we have to take 1 and subtract it. Oh, my 1 is funky. 1 minus that number. So that gives us, oh, that's not the right answer from my calculator because I didn't ever put that number in my calculator. Okay, so that gives me 0.0228, which I'm going to type in, see if it likes that. Not if I accidentally hit another number. And I got it. Oh, that's loud. Sorry.